Okay, so we are going to review the distributive property today. It begins on page 48. And here's your first little example. And this is a pretty basic little example. Mark was telling us how we could show the distributive property with this example. So say it again.
You could do 7 times 20 minus 7 times 4.
That way, minus 7 times 4. And then we could actually multiply those things, right? So the distributive property allows us to share, distribute multiplication across addition or subtraction. There's more than one operation involved. So in math, we usually call it addition. This would be adding what? Rather than subtracting 4, we would call this adding -4, right? Adding -4. So you could call it that. Or, as Mark said, we could look at it as 7 times 20 minus 7 times 4. Now, because it's 20 minus 4 in the parentheses, could you just call that 16?
Yeah.
So that follows our orders of operations, right? When you have real numbers, you can subtract them like that, and often we would. But I asked Mark to show us the distributive property with this example, so that's what he did. Let's see what this looks like as a rule. 7 times 16 would be the same, huh? Okay, so let's see if you can finish the rule. And we go.
It would be A times B plus A times C.
Good, so we're distributing this multiplication across addition, exactly how you said it. There you go. And this works with subtraction as well, as long as you keep the sign. Although in most cases I want you to add the opposite because there's a lot of negatives this year. But Miles, finish this one for us.
A times B minus A times C.
Good, so there it is in a subtraction form. So let's try this with a real expression. Here's an algebraic expression. I see a variable. So we can kind of think of this in expanded form first. When we do, what are we multiplying -8 to here, Brianna? -8 times what? If it helps you to draw those little arches in, you can do it like we did here. This would be -8 times what? -8 times k, and then -8 times what? 4. So you could kind of expand that. I guess last year we actually called that -32. -8 times 4 is -32. Now, is there a simpler way to write that? Rather than writing -8k plus -32, how could you write that in a shorter way? Val, do you know? It's a lot of writing, so is there a way to reduce this adding a negative back down?
-42k.
Well, -8k, can we combine that with -32? Why not? I hear no. Why not? Does the 32 have k's with it, the -32? No. So these are not like terms. You may only combine them when they are like terms when it comes to addition. So we have to leave it this way, but instead of writing this as plus and all these parentheses and a negative, how can you write that? You want to say, Kyle?
-8k minus 32.
Minus 32. It's a simpler way to write it. Okay, the plus and negative is the same as subtracting. So when we perform this distributing of multiplication across addition or subtraction, we are finding equivalent expressions. And equivalent expressions just means expressions that are what? Equal in value. Okay, they're equal in value. So up here, the very first example, one way to write this value is 7 times the quantity 20 minus 4. Another way to write it is 7 times 20 minus 7 times 4. And I guess we could even simplify that further. There are many equivalent expressions, right? Let's see. What's an equivalent expression for 3 plus 1? Giselle, what's 3 plus 1? So we could write 3 plus 1, or we could write 4. With an algebraic expression like that, we could write 5 times the quantity 2 plus x. Or how could we write that, Audrey?
5 times 2
Which is
10
10 plus,
plus 5 times x.
which is 5x. So there you go. We're just finding equivalent expressions by distributing today. Let's use the distributive property to find the area of a rectangle. And you know the formula, whenever we're asked for area or perimeter, we start with our formula. And there's a couple ways people phrase this, especially for rectangles. People tend to use a very common language, not necessarily the math language. What would you say? How do you find the area of this rectangle, Matthew? Or any rectangle?
10 to the first number.
Can you just give me the formula? Area equals what?
A equals
Very good. That is the geometry way of saying it. That's what I like hearing in here. What is the other way people say it, like out in the, sometimes in the real world with rectangles? They'll say A equals length times width. They'll say that. And the thing about it in geometry is we have all these different kinds of polygons, and we need to figure out where their bases are and heights. And it's not always a width thing, you know, so that's why this is the best way to say it in geometry or in math class. Okay, so what is our, let's start with our height, because I just see one number there. So what is it, Matthew? So we have 10 feet for the height, and then we're going to multiply it. So I've actually switched these around to height times base. By switching them, what property have I just used?
Commutative.
Commutative, right? Commutative property of multiplication. Moving, commutative. Okay, so we have 10 feet, and now to find the base, what must we do? Right here. That base of that rectangle, what must we do? Matthew?
Add 12 and 22.
So 12 feet plus 22 feet. So now you can see why this might use the distributive property. It's really easy to multiply by tens. So we have a choice, I guess. We could distribute the 10 across, or we could add what's inside and then distribute it, or multiply by 10. But since we're talking distributive, let's distribute it. Okay? So Cooper.
I just have a question.
Uh-huh.
How can we add 12 plus 22? Is 22?
Because look at this whole base of this rectangle.
Well, then choose
It's 12 feet plus another 22 feet.
It's 22 feet also
If you look at this whole entire thing as one big rectangle, see that? Then it involved 12 feet here and 22 feet there. They're showing you two different pieces to that one side. We're calling it the base. Okay? So it's almost like there's two rectangles brought into one, right? That's what we're doing by adding. So let's show our distributive property, since that's what we're practicing. And 10 times 12 is?
20.
120. You just add a 0 to that 12. Now what happens when we go feet times feet? What do we get? Feet times feet?
Feet squared.
Feet squared. Okay? And so when we're talking area, you literally are imagining how many little squares, you know, that we put in here. And these squares are 1 foot by 1 foot on each side. That's what area does every time we do it. We're saying how many square things are in there. In this case, it's square feet. Okay? So that's why our units are squared. Plus, we have 10 times 22, which is 220 feet squared. And when we add those two, we get
340. Feet squared.
340 feet squared. Okay, go ahead and try it with number 2, and we'll come back and check. Looks really good. She has the formula. Is showing some distribution here. Even though, could you add 9 plus 3? And call it 12 times 14? You could. But she was showing the distributive property. And then the answer, 168 meters squared. So we could actually literally draw, imagine that would be very huge. Because as we look at a meter stick here, this is a meter stick. So a square meter This is a little shorter than a meter stick, so I'll extend it out a little bit. This is 1 square meter, imagine, every side filled in. So imagine having 168 squares that size. That is really a small scale drawing of something really huge, right? So that's what it means when you're talking area. Okay, try these and then come back and see what we have here. Okay, so again, the number 4 was trickiest because of the subtraction. So you need to change your subtraction to adding the opposite and be real careful to note what signs you're multiplying now. -4 times -7 is positive 28, and -4 times -10 is positive 40. So he did a good job there. And do it up here. Is it possible we could distribute multiplication across 3 terms? Is it possible? Yes, we just do a triple distributing. Okay? So again, people, you don't have to draw the arches, but it helps people remember that we're multiplying. 5 times -8 is,
Negative 40.
wait till I call so everyone can think, plus 5 times -3 is,
Negative 15.
good, -15. And then the final distribution is 5 times a positive 10. And that is 50. So now we're right back to adding integers. And again, got to keep close track of these signs. I have 2 negatives right here. So they're both negative, so what will we do right there? Skylar. We're adding -40 and -15. We don't need to do any changing. We don't have any subtraction there. We only have addition. So we just add them and give it what sign?
The positives.
We give it a negative sign because they're both negative. So Skylar, what is -40 plus? -55. And now when we add a positive, what operation are we using?
Subtraction.
Michael, what is -55 plus 50? Positive or negative? Negative, because the larger absolute value is negative. Okay, so we can't, it is possible to distribute across 3 terms. Could a person just add these 3 terms up though? Yes, but in algebra we often don't have real numbers, we have variables. So let's try, you know, there's too much talking. Let's try these 2. And there you go. With number 15, we actually simplified what was in the parentheses and called it 20 plus m before we multiplied across. So now we're going to try some really tricky ones over here. The trickier one is number 17 actually. And then we have one that's all positive, so number 18. So try this and come back and see what you can do here. And there is her beautiful answer. She simplified what was in parentheses, watching out for negatives, and then she distributed the -24 to both terms. Number 18 is a little simpler because there really is no subtraction. So, and come on up, Cooper. Okay, so here we have a great example again of simplifying the expression in the parentheses and then distributing. 35 is the factor that we're distributing to each term. He shows his scratch work off to the side, so his expression can be brought down each time a little bit simplified. This is mental math with the distributive property, and it's really useful. I mean, you could go take and write these numbers down vertically and do some long multiplication to find 7 times 15. But really 7 times 15, we could imagine, is really 7 times 10 plus 7 times 5. Or 7 times, I guess I could write it for you, 7 times 10 plus 5. So when you look at 15, in your mind you can say, what is 7 times 10?
70.
And 7 times 5?
35.
And 70 plus 35 is? 105. Okay, so let's see how fast we can do it. Use our mental math. No, everybody fold your hands. No pencils. And you're doing exactly that. So 4 times 23 is 4 times 20 is?
100.
4 times 20 is?
80.
80. And 4 times 3 is?
12.
80 plus 12 is?
92.
There you go. Try it again. Ready? No, you're not writing it down. Mental math. 12 times 10 is?
120.
And 12 times 8 is?
96.
120 plus 96 is?
216.
Is it 260?
Wait, what? 96.
120
Oh.
plus 96 is, I think it's 260.
Yes.
Yeah.
It's
Let's try it again. Let's see who the first person is who can say this. So everybody quiet, do it in your head. Ready? A prize to the winner.
90.
Say it.
190.
152.
There it is, 152. So 8, he said it, 8 times 10 is,
80.
and 8 times 9 is? So if it was 80 plus 80, we'd be at 160, but it's 80 plus 72, so we're at 152. Congratulations. Okay, next one, ready? Now Luca can't say it, somebody else has to. Say it. Say it.
64.
Plus quiet, quiet, I don't hear it.
116.
And there is your assignment.